So we are now on our last video about the moons, part 3 of 3, and finally we are looking at the tides. So by this point we've discussed the phases of the moon and how they are created. We've talked about eclipses and how they occur. And lastly, as promised, we are exploring the tides. So let's look back at our moon and Earth picture that we've come to know so well at this point. Now, Earth has gravity, and that's why we don't fly away from it. You should know at this point what gravity is. It is the force of a large object pulling us towards it. So the larger an object is, the greater the gravity. All objects have gravity, but the larger an object is, the greater pull it has. The largest object to us has the greatest pull, and in our situation, the Earth is the largest object to us, so that's why we are bound to Earth's gravity. The moon also has gravity. The moon is the largest nearby object to us. So the moon has gravity, but of course it's not nearly as strong as Earth's, because if you remember the size of the Earth to the Earth is much, much bigger. However, the moon's gravity is strong enough to pull weakly on Earth. So the moon does pull very gently on Earth. And the gravity of the moon is not really strong enough to actually pull the Earth towards it for us to even really feel it. But believe it or not, the moon's gravity is strong enough to pull the water of Earth towards it. So this creates a slight bulge in the water. Now the Earth is a spinning object. We know it spins once every 24 hours. Let's focus in on this red dot. So this red dot would spin around once, coming back to its original position every 24 hours. Now if you notice, the Earth is not displayed here as a round circle. We have the inner white circle showing what it would look like if there was no bulge, but here the outer circle represents what it looks like if there is a bulge. Now the only negative part of this picture is the fact that it shows the land bulging outwards as well. That's not the case. The water only would pull towards the moon. So looking right here, you see the water pulling towards the moon. Now the side that's facing the moon at the time pulls towards the moon. But as you know, the Earth is spinning. So whatever part of the Earth at that time is facing the Earth is where the water will be pulled towards it. So every 24 hours, every point on the Earth eventually goes through this bulge. So the bulge itself doesn't move. The bulge of the water, the pull of the water, doesn't move because the moon, at this point, for one day at least, remains relatively stationary. While we know it is orbiting, it's orbiting slow enough that for all intents and purposes, we can say that the moon is standing still. So the Earth moves around, and as each portion of the Earth passes by the moon, the water gets pulled towards the moon. So we experience a high tide as we pass around the moon. You can guarantee that there's a 50% chance that whenever you're at the beach and you know it's high tide, the moon is somewhere overhead. So this happens during the night, it can happen during the day, but if we're passing under the moon, we are experiencing a high tide. Now, you obviously are probably thinking at this point, I'm looking at this Earth here, and I'm seeing, well, one bulge. You promised me one bulge towards the moon. That makes sense now because the moon's gravity is pulling the water towards it. But then why do we have a bulge on the opposite side of the Earth? Well, the reason we have bulge on the opposite side of the Earth is due to something called centrifugal force. And centrifugal force is a force that we've all experienced before, but we might never have named. Centrifugal force is the force pushing outwards on an object as it spins. So if you've ever been in a car that's turned very sharply, or you've taken a bucket of water and tried to spin it over your head, or you've maybe taken a lasso or a ball on a string and twirled it around, perhaps you were on a spinning ride or a carousel, maybe you went to the boardwalk or the carnival and you went on a spinny ride, so you felt like your body being pulled in a certain direction. That is due to centrifugal force. When an object rotates, it causes centrifugal force. So right here, the Simpsons would be turning to the left, and everyone's being pushed towards the right. So whenever an object spins, it pushes things outwards away from it. So let's relate that now to our Earth. The Earth is a giant spinning object. So as it spins, it pushes things away from it. Now normally this force isn't strong enough to break the Earth's gravity. However, once again, in the case of the water, it's enough for the water to be pushed outwards. So that's where we get our second bulge from, is the water of the Earth being flung or pushed outwards as a result of centrifugal force. So imagine this water being pushed outwards, just like the Simpsons being pushed outwards as they turned. This water gets pushed outwards as a bulge. So that gives us our second bulge. So that's why we have two high tides at any given time on Earth. One high tide is caused by the moon pulling on the water. The other high tide is caused by the bulge as a result of centrifugal force. So this red dot now, as it goes from its starting point all the way around during a 24-hour day, will go through one high tide and then back around again to two high tides before it reaches its spot. So we have a high tide about every 12 hours, and tides change every 6 hours. So when it's not experiencing a high tide, it's experiencing a low tide. So we have high tide, low tide, high tide, low tide. And the tides stay in the same spot on a given day, but the Earth itself moves through the tides. So I want you to take a look at this picture. You might want to pause the video, play it back a couple of times, look at the relationship between this red dot and what's happening in the picture, and see how the Earth moves. Again, the bulges themselves are staying in the same spot. The Earth is what moves. So, we saw what creates the tides. Now let's look at the different types of tides that we have. So, when the tide moves from low to high, it's called a flood tide. So when you see the Earth moving from low tide to high tide, we call it a flood tide. When the tide is moving from a high tide to low tide, it's called an ebb tide. Tides change every 6 hours, with 2 high tides and 2 low tides each 24-hour day. So these 4 points on this Earth, A, B, C, and D, represent 4 different tides. So the first letter, A, represents a high tide. The moon's gravity is pulling on the water, creating a high tide. At this location on Earth, B, we're experiencing a low tide. So the water is being stretched by centrifugal force in this direction and by the moon's gravity in this direction. So B is a low tide. Now, as we said before, when the tide moves from low to high, it's called the flood tide. So point C is moving from low to high. It's called the flood tide. Finally, now it's moving from a high tide to a low tide. We call that an ebb tide. So there's 4 tides, and this happens through a 24-hour day. So every 6 hours, the tide shifts. So it takes 6 hours to move from point A to point B. We experience 2 high tides a day. So every 12 hours, we experience a high tide, and every 12 hours, we experience a low tide, for a total of 4 tidal shifts every day. Position of the Earth, Sun, and Moon affect how deep or shallow a tide is. So the severity or extremity of our tides changes depending on the position of the Moon around the Sun. So we have 2 different types of tides. We have spring tides and neap tides. Spring tides are more severe tides. They cause higher high tides and lower low tides. If you've ever been to the beach and seen the water very, very shallow to the point where you feel like you can walk out and not even touch water, you're likely at a low tide spring tide because it's very low. At the same time, the high tide, when it goes towards high tide, will be very high. This is caused when the moon is either when the Earth, Sun, and Moon are in a line. So it occurs during either a full moon or when it comes back to a new moon. If the Earth, Sun, and Moon are all directly in a line, we call it a spring tide, and it causes higher high tides and lower low tides. You can see during this picture, spring tides, the water bulges outwards just a bit more. Neap tides is our other option, and when the Sun and Moon are at a 90-degree angle, we know that's during our first quarter and last quarter tides. It produces more even tides. So that means the high tides will not be as high and the low tides will not be as low. There'll be less of a difference between high and low tides. So again, I want you to take a look at this picture, rewind this image if necessary, and you can always refer back to my PowerPoint that should be shared with you, and really just study what's happening here. Look at the difference between a neap tide and then a spring tide, a neap tide, and then a spring tide. You should see the differences between them and know how they're created. So when the Earth, Sun, and Moon are in a line, it's spring tide. When they're at a right angle, 90-degree angle, it's a neap tide. So that concludes our introduction to the tides activities. You should at this point now be able to predict when a tide will occur and explain how those tides are occurring.